Okay, good evening, everyone. It's me again. So, the topic today is quantitative flow measurement. In a simplified version, it's just a from to charts. So, what is a from to charts and why do we need them? So, firstly, we need a from to chart to measure the material flow between departments. You need to know the relationship between the departments, and you will base that on the number of material flow between them. And just keep in mind before we go to an example, a from to chart does not need to be symmetrical. It can be asymmetrical. So this is a from to chart. As you can see, for example, here we have 7 departments right here. And let's pick a random number. So what does this number 7 mean? It means that uh, the material flow from the milling department to the plate department is 7. Okay. The bigger the number, the bigger the bigger the flow, the more frequent the flow. Okay. So there is up to 12 flow that goes from the store to the milling department. However, from blade to turning, there is only one. So we will, when we design, when we decide where to put the department, we should put the department with the high number of flow close together so that you can move around in a convenient way. And for the department which only have a very low number, for example, number 1, you can put them far far from each other a little bit. That's fine because you don't move between them that much. So that's the idea of the from to chart. And just remember, it doesn't mean need to be symmetrical. So for example, from blade to uh, milling, it's 3, right? But from milling to blade, it's 7. So the from to flow can be different. Okay. Now, um, let's go to an example. So let's say that there's a firm. It had 5 departments and it produced 3 components. And this department lays in a linear arrangement. So department A will be here, C, B, D, E. It's just like this. Okay. They sit next to each other in a linear way. Okay. And component 1 and 2, because they have the same size and weight, so their movement is the same. But the component number 3 is 2 times bigger. So moving 2 units of component 1 will equal to moving 2 units uh, of component 2. Okay, because they have the same size and weight, and 2 of 1 and 2 of 2 will equal to moving 1 unit of component 3, because component 3 is twice as large. So for example, when you move components 1 or 2, you only need 1 person, but to move component number 3, you need 2 people. So you will count moving 1 unit component 3 as 2. Okay. So yeah, we will assign a movement factor, which is just a multiplier number to component 3. And I'll show you the example in the Excel file. Okay, so right here we have the information given and the table. So here you can see that we have 3 components and the quantity to produce each day, the movement factor, remember, because product number 1 and 2, they are the same. So they have the movement factor equal to 1. And because component 3, its weight is twice as large, so the factor is 2. Yeah, so we have to so we calculate the equivalent flow by multiplying the production quantity with the movement factor, and we will receive this. This number is very important for the from to charts. Okay, so let's dive into the from to chart here. The column is from and the row is to. Now let's look at component number one first. The routing the routing is A, C, B, D, E, right? So the flow is 30. Firstly, we move from A to C, here, 30, right? But I'll mark it as 1 to remind me that, oh, this number 30, this flow of 30 is component number 1, okay? And then from C to B, okay? From B to D, okay, right here, B to D. From D to E, okay. So we done with component number 1. Now, component number 2, we have the equivalent flow of 12, A to B to D to E. Firstly, A to B, right? A to B. So we mark it as 2 so that we remember, oh, this flow is of component number 2, 12, right? From B to D, right here, from B to D. Okay, but we already have this, so we put the number below. And from D to E, from D to E, okay. And yeah, now we move to component number 3. The equivalent flow is 14, A to C to D to B to E, A to C. Okay, A to C, C to D, right here, right? D to B, okay. And lastly, B to E. Okay, right here. Um, now we need to sum of the flow here. So from department A to department C, we have the flow of component 1 is 30 and the flow of component 3 is 14. Now we will sum them together, okay? Because we are interested in the total flow. We don't care that much about the individual flow of each component, okay? So this is 44. This total is 12. 12. This is 30. This is 14. This is 42. 14, 14, and this is also 42. Okay, so now for you to see it easily, I'll transfer it to this table. Only copy the total value, okay? 44, 12, 13, 14, 14, 14, 14, 42. Okay, so now we have this from to table as our final result. The blank cells are number 0, so there are no flow between them, so you don't need to care about them. So what can we do with this from to chart? So as you can see here, from A to C, there is 44. There are 44 flows, and from C to D, there is 42, and from B to B, am I wrong or something? Wait a minute. B to B. Okay, my apologies. It's ACB, not ABC. Okay, and we look at these number from A to C, from C to B, and from B to D. The numbers of flow is very high. So maybe when you design the, how do I say, when you design the facility, you need to put them close together because the flow is, how do I say, there are a lot of flows between these departments, so you should put them closer together to minimize the time travel of the material. But for example, maybe from A to B, there's only 12, so maybe B doesn't need to lie this close to A. Okay, so the from to chart usually will determine the distance between the department. It can be the material flow or information flow or something like that. So I believe that's it for this video today. Thank you for watching. Again, if you have any questions, just remember to comment in the comment section. I'll try to accommodate your question. Thank you for watching. See you in the next video.